Today we are looking at compound and independent events. Compound events means that more than one thing could happen. Compound events are basically using the word or. So the probability of one thing or another thing occurring. I don't know that we've really used this notation very much, but this means the capital P means probability of A or B is the probability of A occurring plus the probability of B occurring. Basically, the word or means that we are going to add things together. A card is randomly selected from a standard deck of 52 cards. What is the probability that it is an ace or a face card? We kind of did this yesterday already. How many aces are there? 4 aces. And how many face cards are there? There's 3 per suit, 4 suits. There's 12 of them. Or basically means you're going to add those together because you'd be okay with either of them happening. So there's 16 possible options out of the 52 cards. Now, the way we did that doesn't really look like this formula. This formula is saying that we're supposed to take the probability of one thing and the probability of the second thing and add them together. But because these are fractions, the probability of getting an ace is 4 out of 52. The probability of getting a face card is 12 out of 52. If you add those two fractions together, you end up with 16 out of 52, which is the same thing. So whether you add them together and then put them over 52, or whether you do the probabilities separately and then add them, you're basically going to get the same thing. So the probability of drawing an ace or a face card is 0.308. The thing that you really have to worry about is, what if it says, what is the probability that it is a queen or a face card? What's the problem with that? A queen is a face card. So then you can't use duplicates. You can't say 4 out of 52 plus 12 out of 52 because then you've counted the queens twice. So you just have to make sure that you're not counting things twice. A card is randomly selected. What is the probability it is a 2, 3, or 4? So there's 4 ways for it to be a 2. There's 4 ways for it to be a 3. And there's 4 ways for it to be a 4. That is the same as 4 plus 4 plus 4 is 12. So there's 12 out of 52 ways that this could happen, which is 0.231. So compound events really isn't anything very new. Count up the number of things out of your total number of options. Independent events are a little bit different. Independent events, you're looking at the probability of one thing and another thing happening. The probability of A and B occurring is the probability that A occurs times the probability that B occurs. So basically, and means multiply. Or means add, and means multiply. 2 cards are randomly selected from a standard deck of 52 cards. Notice 2 cards are being selected. What is the probability that it is an ace and a face card with replacement? So first we're going to pull a card out and see what it is. We're going to stick that card back in, make sure it's still random. We're going to pull another card out. The second time we want it to be a face card. So our first card, we have 4 possible aces out of 52. Our second card, we want it to be a face card. There's 12 of those out of 52. We have to keep it separate this time because we're using multiply. When we calculate this, there's several ways that you can do this. Honestly, your calculators are a lot smarter than we give them credit for. You can do 4 divided by 52 times 12 divided by 52. So you can just do 4 divided by 52 times 12 divided by 52. You should get the decimal 0.01 0.775. I'm going to round that to 0.018. The other thing you could do is multiply straight across the top, straight across the bottom. So 4 times 12 is 48. 52 times 52 is 2704. And then you could divide those to get that decimal. You could also do parentheses 4 divided by 52, parentheses 12 divided by 52. There's several different ways that you can enter this into your calculator. Try this out in your calculator. If you get 0.018 after rounding, you entered this correctly. The next thing we need to talk about is, what if we don't replace the card? So I've got 52 cards in my hand. We're going to pull one card out. We want it to be an ace. We're going to set that card on the table, and now we're going to pull another card out. We want it to be a face card. So our first card, we have 4 aces in the deck out of 52 cards total. How many face cards are potentially in the deck? Still 12, but how many cards do we have to choose from this time? 51. We've taken one card out. There's only 51 cards left, so we have fewer cards to choose from. Again, however you want to enter this in your calculator is fine. 4 divided by 52 times 12 divided by 51. If you get 0.0181, I think I'm going to take these numbers out a little bit farther. So this one was 0.0178. I'm going to take it 4 digits out because that will help us to distinguish. These numbers are very, very close to each other because really we're only talking about one card difference. This gets more different if we're talking about, what if we're drawing 4 cards and we're not replacing it and we're trying to get like the same thing every time? Okay, we're actually going to change C and D because I don't really like them. Because I can do that. What is the probability that you get, we're going to do an ace and an ace. And then we'll do the same thing down here. We want the probability of getting an ace and an ace. Okay, so first we do with replacement. I'll bet you could do this one on your own. There's 4 aces out of 52 for the first card. There's 4 aces out of 52 for the second card. Calculate that. Next, we're going to do the probability that you pull out an ace, set it on the desk, you pull another card out and get another ace. This one's a little bit different. The first fraction is the same. If we've got a full 52 card deck, we have 52 cards to choose from, 4 of them are aces. And means multiply. What about the next fraction? We know it's going to be 51 on the bottom. Here's the thing with probability. You have to assume that you got what you wanted with the first card. So if we successfully pulled an ace out, there are now only 3 aces left. This is kind of a weird little gray area in math. We don't know if we got the ace, but we have to assume that we got the ace. As far as we know, there are only 3 aces left in that deck that we could pull from. So if we calculate this, 4 out of 52 times 3 out of 51, you get 0.0045. Now these numbers are so small that it's hard to even comprehend what they mean, but do you see how example D is a smaller number than example C? So if you put the card back, you are more likely to get the card that you want. If you don't put the card back, you're going to have less of a chance. So imagine doing 4 cards, an ace every time. 4 out of 52, 3 out of 51, 2 out of 50, 1 out of 49. Multiply that all together, that would be a very, very low probability that you would get all of those cards. You roll a standard 6-sided die, flip a standard coin, and spin a 4-color spinner. What is the probability that you get 2 heads and red? I'm going to see if you can do this on your own. Pause the video, try this one on your own, see if you can figure out, remember, and means multiply. Okay, a standard 6-sided die has 6 options. We want to get specifically a 2. There's one way to get that 2. A standard coin has 2 sides. We want to get heads. There's one way to get that. And a 4-color spinner has 4 options. We want specifically the one option that is red. And means multiply, so multiply these all together. 1/6 times 1/2 times 1/4. You should get 0.0208. That is like a 2.1% probability. Okay, next we're going to revisit number 12 from worksheet 2. I don't know if you remember this one. A committee of 4 people are being selected from 7 women and 5 men. How many ways can the following be selected? Really, for 2 women, we've got, because it says and, 2 women, we would do 7 women, we're choosing 2 of them. For the 2 men, we have 5 men, we're choosing 2 of them. We would multiply those together because and means multiply. All women, 7C4. 3 women and 1 man. Anyone want to take a crack at that one? 7C3 and 5C1. So we could calculate those out in our calculator and get the actual numbers. To save on time, let's just move to the one that's actually probability. The committee membership is being randomly selected. Each candidate is equally likely to win. The committee will be made up of 2 women and 2 men. So we are going to focus on this one. You have written down who you think will win, who you want to win. What is the probability that your choices are the winners? Well, there's the one way that you have chosen for those committee members to win. How many possible choices are there? That would be this number up here that we haven't calculated yet. So if we calculate this thing up here, we get 210. So there are 210 ways for those committee members to be selected. We want our one way to be the winner. We have that'd be 0.48, 0.0048. A 0.48% chance that our selection is the winner. That's not very likely.